Hello everyone. This is our second lesson of the module 2, and before we start anything, I'm pretty sure you are familiar with these. I just put some interesting pictures, diagrams. Okay, you must be thinking why we are looking at those. Today's lesson is we are going to look at, or we are going to analyze this type of motion. We call this as two-dimensional type. Remember that in first week we learned something is moving along straight line. Could be horizontal direction or vertical direction, right? Okay, this way or this way. And we did work on some problems. And then in my first lesson, in module 2 or V2, we talk about vectors. Okay, and you know what is a vector and what are the special properties, how we can get the component more specifically. Okay, and now today's class we are going to combine those two. We are going to use whatever we learned in first week, and we are going to also use what we learned about vectors, okay, mathematically. And now you see that physics is a cumulative process. In other words, you cannot just skip week 1, skip lesson 1 and just come back and check here. Okay, if you have previous background, you might be okay. If not, just go over previous materials and try to understand those things and then come back and start from here. Okay, and again another pictures, very nice. And this is, look at this photograph, right? And somebody is shooting a basketball, and this shows that this diagram shows the path of the basketball. Okay, and why, can you think why this one is turning at this point? Why this ball is not go up high forever? Okay, or this is just another snapshot of tennis ball, the path of the tennis ball. Why this is not going up forever? Or last class or last week we learned that even if you just toss something vertically upward, still this is going up, up, up and turning back somewhere here. Okay, but this one has a different path. Look at that. We call this as projectile, or this path we call, because it shows a parabolic path. Okay, and this object, whatever this object, we call projectile, which has some special meaning. Projectile means it is moving two-dimensionally. You can see that it is not moving straight horizontally, or it is not going this way, but it is moving in this 2D plane. Okay, we call this is positive y, this is positive x. Okay, and this is moving on this two-dimensional plane, and this is the real important part here. It's moving under gravitational acceleration. So that explains why this is turning here. It goes up to certain height and it is going down, because what happens, this gravitational acceleration, G, is gravitational force, is pulling the ball downward. Okay, we talked about the gravitational acceleration last time. Remember that we use G. Okay, and usually we talk, right, acceleration A, and we use AY. Why? Because gravitational acceleration is always, do you remember the direction? I mentioned many times that gravitational acceleration, if it is an acceleration, we know it is a vector. Therefore, we need to take care of the direction. Gravitational acceleration, this is really important, always vertically downward, right? This is the direction. And instead writing positive, negative g, because if I ask in my face-to-face classes, what is the g? Most people say it is negative 9.8. Not incorrect. You're right, but you are missing or you are giving partial information. Okay, negative sign tells me the direction. Okay, if you're right, you are keeping right. You know you are taking going upward as positive. If you take that as positive, you are right because g is downward. Therefore, g would be negative. Okay, instead memorizing positive negative sign always, I would say g, gravitational acceleration pointing downward. Therefore, the g positive or negative depends on your coordinate system. Okay, so now let's look at this one. So the motion of the red ball we learned or we talked about last time, because something is moving under gravitational acceleration, right, vertically upward or downward. We talked about this one last time and we did many problems, remember? And now this red ball shows you the motion of the red ball is you drop something with certain height. Let me show. Okay, you drop something from here. Okay, when you drop something means your initial velocity is 0. So then what happened? When it goes downward, it gains speed, right? And this is moving under constant gravitational acceleration, which g, a magnitude of the g is 9.8 meter per second squared. So that means at each second, this gains because speed by 9.8. 9.8081 books use different numbers. Okay, remember that acceleration, meaning of the acceleration is change in velocity. So the meaning of this 9.8 number is each second its velocity is changing by 9.8 because acceleration v delta v over delta t mathematically, or change in velocity over time. Okay, now we are clear about the motion of the red ball. Okay, now the yellow ball, what this diagram shows you, at the same time, okay, you drop this one and you shoot or you fired horizontally. You just fired horizontally the yellow ball, okay, and that means this one has some velocity. And then what happens? So this is the path. Now this one takes some parabolic path and we are going to analyze this motion, okay? And what I mean is I can find out, okay, what is at any point. For an example, if you take, this is the position of the ball, oops, this is the position of the ball after 1 second. And I should be able to, for an example, if I want to, I should be able to find out at after 1 second how fast this is moving and what is the position of the ball, so on. All information about the motion doesn't matter when it is here or here, okay? And that is the purpose of this lesson. And this is one special one because you just project or fired this one horizontally, but we'll look at the other ones too. Okay, this is the same thing. and this is what I just explained. And what is this ax and ay? And because if I look at two-dimensional, I need to look at the x and y motion. And why this ax is 0? We already explained that, because this we are looking at the motion under constant gravitational acceleration. And in other words, we have a vector g vertically downward. And that means if I look at the x, this is the acceleration. Okay. And so remember, we talk about components of vector. If a vector is completely in y direction, then what is my x component? X component is 0. So that's why this is 0. We in first lesson here, when I get the vector component, I did not mention acceleration or velocity or anything. We talk about vector A, vector B. I had a exercise. I gave you 9-10 vectors and we worked on how to get the components. We know that if something vector B is something like that, then we know Bx is same as here, but By, y component 0, right? Remember? Okay, same story here. So that's why this acceleration in x component 0. Okay. And now, because now we are working on projectile motion, which is moving under constant, moving under g, right? Okay. And this is our projectile motion. G is acceleration and G vertically down, and this one magnitude is always 9.8 meter per second squared. Okay, and we assume that this G is constant and there is no air resistance. We ignore those effects. Okay, and now we are, in other words, we are talking about something is moving under constant acceleration. And this we have special type of acceleration, which is g. We know the number, which is 9.8 meter per second squared. Okay, if book says 9.8081, you could use here see 9.81. All right, and don't worry about that too much. You could use 9.8081. Your answer would not change much. Okay, now we are going to look at something is moving under constant gravitational acceleration. And we are familiar with these equations. Remember that in week 1 we saw this type of equation set, and you might have in your equation sheet now those, and now you should know what this each letter represent. If you know what Vx, V0x, Vy, V0y, you should be good. Okay, and nothing new. We are going to apply these things for x direction and y direction separately. Remember? And x stands for position. Here what do you mean by x naught? Initial position, initial x position, initial x direction velocity, initial y direction velocity, x direction acceleration, y direction acceleration. Okay, but our life is going to be very easy for x direction. Why? Because g is 9.8, therefore acceleration is always in y direction. Therefore, for projectile type motion, x direction acceleration 0. So this is going to be 0. Okay, at the very first time, this is what you should write. for the problems. There is no acceleration in x direction. Therefore, you will get very simple equations for x direction. Okay, so this is the big idea. You can read. This is what I explained so far. Okay, and now, because there are many type of projectile motions, so these two diagrams shows two of them. The other one would be something like this. You kick a ball with certain angle and it goes up and okay, so let me draw something like this. Okay, this shows the projectile type motion, x direction, y direction. You could kick with certain velocity. Okay, it's the same thing. And now you would read something called launch angle. Launch angle is defined, or launch angle is the angle between your initial velocity and with respect to the horizontal. Okay, in this case, this diver, okay, this is the diving, this is horizontal direction and this is her initial velocity. Okay, make sure, and if I draw the velocity, I would draw this velocity as, sorry, here, right, V naught, and make sure I don't have any x or y. We'll take care of that later. Okay, so this is your V naught, and in this case y theta 0, because now my V naught is parallel with the horizontal direction and it does not make any angle. Okay, and if I look at this one, my V naught would be this here. Okay, all right. And we are going to look at these three types, and I will show you nothing is going to be different. Okay, we are going to apply for each situation. Okay, now this is one special case, or we already saw that, and you are going to project something horizontally. Okay, so this is the situation. You project something horizontally, V naught. Okay, and since your initial velocity is complete horizontal, I know my initial y direction velocity is 0. Remember, velocity is a vector. Okay, and if you look at the components, y direction 0, therefore your initial velocity is going to be just on the x direction. Okay, you have a vector. Go back to the lesson 1, and vector A, in our case this is my initial velocity V naught, and completely on horizontal direction. We are going to look at the components. Then y component would be 0 because it is horizontal. That's why you see that here. Okay, and don't worry about the symbols here. Use XO. Earlier in equation sheet we saw OX, right? Just idea. I don't mind what you use. Some books use VXI. X direction, initial velocity, whatever. Okay, and look at that. Now, when initially this is horizontally, and but when your ball is at this point, this velocity is along here, and when ball is here, velocity is along this green arrow. Okay, that is the velocity of the object, but it is not easy to explain or find out the velocity in this way. Okay, because this is not x direction, this is not y direction. Therefore, what we can do, we can break this one into x and y direction motion separately because they are independent. Okay, therefore I break my velocities to the x and y, x and y. These are different numbers. I don't know. We are going to figure those out. Okay, and x and y. Then you could discuss the x direction motion separately, y direction motion separately. Okay, and instead talking, let's apply these conditions or what we learn. Okay, again, nothing new. We are familiar with the equation sheets. We are going to apply those things, and I will show you how to do those things in a simple way. Okay, no matter what, the first thing is draw simple diagram. Okay, this is not a math class, therefore just draw a simple diagram on your paper and choose your coordinate system. In other words, choose a coordinate system, and so that means tell yourself what is positive, what is negative, because everything depends on that. Okay, if you want, you can always pick x and y as here, and this is not a rule, this is your. Okay, then make a table and write everything you know or it's given and what you want to find out or unknown as in this diagram. Okay, and for the projectile type motion, you know something. You know the acceleration in y direction. I cannot change, you cannot change. This is always g or 9.8, or based on this you can sign the number. Also, you know x direction acceleration 0. These two are always right no matter what for the projectile motion. Okay, and here acceleration, if you pick this, I didn't read even the problem yet, right? You just write the table without reading the problem. And why you pick negative 9.8? Because this is my positive y going up, positive acceleration arrow going down, and it is opposite, therefore negative. And I don't know anything about that. Let's see, ax, there is no acceleration in x direction. Okay, now let's go and read the problem. A movie stunt driver horizontally, so that means it's his initial velocity is in this way. So from this information I know his initial y direction 0, his initial velocity always to the right. Okay, and I don't know, and 50 meters high. Initially he's starting at 50 meters, and how fast must the motorcycle leave the cliff? Okay, in other words, it's asking this v0x. Okay, and some numbers are given. This distance is 90, this distance is 50. Okay, all right. And what is it asking? It is asking me to figure out the v. Okay, all right. Now these are the given materials or given things, and why this y is negative 50. I will explain this one in a minute. Okay, all right. So you are measuring from here, you are starting here, you are at the end, you are here. Okay, and what is my delta y? Delta y is final position minus initial position. Finally, you are at the ground level 0. Initially, you are starting at 50. So therefore, your delta y should be negative 50 meters. Okay. Okay. And now you are plugging the numbers. Okay. And I'm going to, because I know I need this. I need to figure out, my purpose is to figure out Vx. Okay, and if I look at, take this equation, since Ax is 0, that n I'm getting Vx is V0x mathematically. What that means, that tells me at any point x direction velocity does not change. Okay, when you are here or here, and Vx, Vy, since this is not accelerating, that makes sense, right? If something is not accelerating, change in velocity 0, that means it's going with constant velocity. If it had a x direction velocity or x, that's the same. Okay, that's the only information I can get here. And here this part 0. So therefore, this is not much useful for x direction. And I could use this one, but this term is gone. Why? Ax 0. Okay, don't just like a machine, do not write x as acceleration as 9.8, because x direction acceleration 0. This part is gone and I'm ending up with here. Okay, I know x minus x naught displacement 90, and I need to figure out V0x, but I don't know the time. Okay, and time to reach the ground when it goes from here to here. For that, usually in projectile motion, to find the time, you could use the y direction motion. Okay, and y direction motion, now you apply this. Okay, and y minus y naught is, or you could write this as delta y is v naught yt plus half a yt squared. Remember that delta y is the displacement, which is y minus y naught. Okay, and which is negative 50, and this gives you time. Okay, and this is the time to go from here to here, because we know x and y direction motions are independent. When he vertically comes downward in 3.1 second, 19 seconds, so he has always, this person moves horizontally 90 meters. Okay, therefore you know this distance and the time v from this part, and you can figure out the initial velocity, 28.2. Okay, you can go over the math. I am just focusing on the concept here. And 28.2, and that means at any point his x direction velocity is 28.2. I don't know the y direction velocity in this problem. It is not asking, but if you are curious, of course you can find out. Vy, V0y is 0 for this one. Ay is negative 9.8. T you found out 3.19. Then you will end up with, at that point you are getting a negative number. Just below, before it hits the ground, it makes sense. Look at that. If I draw velocities, Vy is downward. Okay, therefore should be a negative number. In this problem, it is not asking. It is asking us to find out the time and the initial velocity. Okay, hope this is clear. And I tried to put all information here. Typing all these equations takes lots of time to type those, but my purpose is to help you and make this all right, all this explanation makes sense. Another problem, same type. Okay, and I will leave it to you, but let me help you to start. Again, same thing from here. Now the velocity is horizontal and the magnitude is 9.0 meters per second. Okay, so that means number is given. Now V naught is given, but I know V naught is should be equal to V0x and V0y is 0. Same explanation, because it's given that this is not always, because it is given going horizontal with magnitude 9. Okay, those are the given things I can write in my table, and always you can write those. What is it asking? Position and velocity after 0.5 seconds. Time is 5 seconds. Position is x and y, because we need to figure out the where is he, here x, and always right, he has some vertical motion too, this is y, and velocity at this point. Okay, all right, this is the diagram. This is all known things, and we know what we should figure out. You already know Vx, because to figure out the velocity, if I look at the velocity, this is the velocity they are asking, but I can't find it directly. I need to figure out the x and y component. X component you already know, because we know from this equation Vx is V0x plus axt. This is 0. That tells me Vx after 0.5 second or after 2 second or after 5 seconds, same as V0x, which is given 9. Okay, therefore you know this one already, but we'll have to calculate Vy, x and y. Okay, okay, pick those equations and use given things, you know most of the stuff. And okay, don't be scared by looking at those all equations. Go step by step. Okay, I'm starting from here. I'm not memorizing anything. I just start from here. I make this is 0. Okay, and x minus x naught, I'm ending up with here, and x naught is your initial point, which is your starting. You can say this is 0, and I'm trying to figure out after time 5 seconds. I know the initial velocity, and I figure out after half second horizontally you have moved 4.5 meters. Okay, that part is done. Now I want not only the x, I need to figure out the y part. Okay, this is my equation, but now I know one thing, this is 0. So that makes our life easier. And you are starting here, this is 0, 0, therefore y naught 0. This is 0, half ay. Acceleration, and I look at my coordinate system. I have this diagram has taken going up as positive. So that's why you see 9.8 t squared. Okay, and don't change anything. Now I get 1.8 negative number. Don't scared about the negative numbers. This has a meaning. And look at that. You are starting from here. You are going downward, right? Okay, at this point, this is the downward. So that is the negative direction. That's why that y, you are starting here and you are downward. So that's why this negative number. Okay. Now you know position. And the second part was asking velocity. We discussed this part. And now to find out the velocity, you know V0, Y0, A by T. Okay. And now let's go back to my vector components. You know VC, this part, you know this part. Okay. And asking here, make your right triangle. You know this V0x is 9. So this is 4.9. Negative sign gives me the direction downward. and asking here, you have a right triangle. Okay, we learn when you get the components. If you have a vector with the A and B, this is the Pythagorean theorem. I use this one to get the magnitude, and you can find out the direction by taking this is Vy, this is Vx. Okay, because velocity you need the magnitude and the direction. Okay, all right. We talk about, or we did two examples under this condition, right? Because this is one special case, horizontal direction. This is this right, because this is really easy. This one, because our V0y was 0 here. Okay, but let's look at the general launch angle, what that means. And so that means, imagine you are kicking a soccer ball. Oops. Okay, and when you kick the soccer ball, you know, right, this situation, and it goes up, and similar to first slide diagram, or this is the motion of the basketball. All right, and if I click OK, and this go up, 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 up high and launch it here. Sometimes books use this R, and R is actually x direction displacement, or x minus x naught. If you say this is hitting at x, you are starting at x naught. This is the x direction displacement. You call it range. Okay, range means horizontal distance. Okay, in this type of, and you will see for Weber sign module 2 homework problems this type. And first of all, what is this V naught? V naught is initial velocity of projectile. Okay, and so that's one. Okay, now your first job is to figure out what is the x direction velocity, what is the y direction velocity. Please don't use whatever this number. If you start with this, that's the whole problem is going to be wrong. Okay, your first job is to figure out x component and y component. We learned this one in lesson 1, how to get the components of a vector. You make your right triangle. Oops. If you are not sure why this is, just use cosine sine relations. You have a vector. Now we call this vector is V naught, this length, and I need V0x, V0y. Okay, and I know cosine theta is adjacent length divided by this length V naught. So that's how you get V0x as V naught cosine theta. Okay, and if you are not familiar with that, go back to lesson 1, check. Okay, and you see that this is positive for this. Again, theta is the angle. Now let's look at this. Okay, this diagram, if you understand this diagram, you are good with all problems. Okay, now this is the initial velocities. Now when projectile is at this point, it has a velocity, but I don't know how to calculate this. You can break into x and y. Okay, now it goes back to here. This is one special point. This is the maximum height it reaches. This is the maximum height. Okay, and at maximum height, why this is not going further up? Because at this point, your upward direction Vy is 0. Vy is 0 at maximum height, but still you have x. In this way, right, your velocity is all completely in x direction. And going back, and okay, this is just before it hit the ground. What else you know? You know, no matter what, either here or at maximum point or here, your acceleration in y direction or acceleration is always vertically down. Acceleration in x direction doesn't matter here, or any point is 0. According to this one, acceleration in y direction is, for this diagram, negative 9.8 meter per second squared, or g, because you take, see, this is my positive y. Okay, all right. What else we can take from this one? What is my delta y for this type of motion? What is delta y? Go ahead. Start from the beginning. Delta y is the displacement. This is the mathematical symbol. Displacement, final position minus initial position. What is my finally? Finally, you are at the ground. Okay, this is 0, 0. Same ground level. Initially, you are starting here. So therefore, y direction displacement for this type of motion is 0. You kick something from ground level and it hit back to the ground. So therefore, a total displacement, y direction displacement is 0. Okay, and no matter what, where the object is, acceleration is gravitational acceleration, ax is 0. Okay, all right. Okay, let me ask you this. The figure represents the, okay, A to E. At point C, the velocity of the ball. This is one special case. What do you think a ball is? Okay, and if I were, okay, before I give you the answer, think about that. Pause the video for a second and think about that. At point C, the velocity of the ball. Okay, and if I were the face-to-face class, and if you were in front of me, if I ask half of the class, from the half of the class, I get the answer 0. So this is incorrect. Now ask yourself why. Okay, it's asking at point C, what is the velocity? Let's draw the velocities. Here, 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 right velocity. Oops, velocity. Oh, I should not this way. Okay, and here what happens? This is your maximum point, right? Your Vy velocity is 0, but it's still moving to the right. There is Vx. We know Vx is always V0x. Okay, therefore, and at this point, since Vy is 0, it has the minimum velocity and it is directed to the right. Most people forget about the velocity. You are right if I ask what is the y direction velocity. Y direction velocity 0, but x direction not. Okay, and this slide explains everything I explained so far with the mathematical equations too. Okay, we know this part, because acceleration 0, half axt squared. So this term is gone, axt. This term is gone because this is 0. And you could use these equations to solve horizontal projectile type problems. Okay. Okay. Now look at this quick example. So this is not from your textbook, therefore a projectile is launched from the original with the initial speed 20. So this V naught is 20. At angle theta 35 degrees. Find the x and y positions. Okay, where am I? X and y positions. position at the time t equals 0.5 after half second. Okay, after 1 second. I'm not going to do all. These are for you. I can show you doing one t after half second. After half second, I don't know where it is. It could be here. It could be here. It could be at max. It could be at already past the maximum point. I don't know. Okay, but let's say you can start from any, and we could, let's say, right, if you ask first find the x naught plus v0 xt plus half xt squared, so this term is gone, and x naught is 0 because you are at the origin, plus v0 x t is 0.5 seconds. Okay, and what is v0 x? Is it 20? No, if you start from 20, your answer is wrong, because v0 is 20, v0x, you need to find out it first. Your first job is, for this type of motion, find out v0x and v0y. I found out it here, v0x, v0y, because that should be my first step. Okay, now you know v0x 16.4, so therefore you know the position. How about y? Y is y naught plus v0 yt plus half a yt squared. Y naught is 0. Vy, you know this one, t is 0.5, half. What is my acceleration? Okay, acceleration g always downward, and my going up as positive, therefore this should be 9.8, 0.5 squared. Okay, my writing is not clear for this tablet, but you can do the math. Okay, you would do the same thing for 1 and 1.5, only thing your t would be different. Okay, and again, first thing, please do not use 20 as your whatever the initial velocity. Based on the angle, you need to find out x and y. Okay, I put all answers. You do your work first, and so let me go back, check my answers. Okay, and again, I have mentioned this multiple times before. Please do not just watch video. Okay, in my videos I'm trying to put more examples, and the best way to check yourself is, before you check my answers, do your work on your notebook and check whether you get stuck. Okay, and if you get stuck, you can check my answers. If you have any comments, if you want to see more work, just let me know. Okay, then I can improve those recordings. All right, another problem. An object is fired from the ground at 100 meters per second. What is this? 100 meters per second. So that tells me this is my V naught at an angle 30 degrees. Very similar to early problem. Calculate the horizontal and vertical components of initial velocity. This problem guides you. Okay, go ahead, find out v0x, v0y. You know how to do this. After 2 seconds, how far the object traveled in horizontal direction? Delta x. How high? Okay, y. I will leave this. This is very similar to early problem. Okay, and I found out v0x, I found out v0y. So that's our first part. After 2 seconds, okay, how far? Horizontal direction. I don't know how far it's here. We'll figure out. In other words, it's asking x, right? How high? Y. Delta y, delta x, but delta x is x minus x naught. Delta x is x minus x naught because x naught is 0. Delta y is y minus y naught. Y naught is 0. Okay, and after 2 seconds you need to figure out x and y position. That gives you the answers for B and C. Okay, and so this example covers everything you should know about this general projectile type motion. Okay, another problem, same thing with different numbers. Please go ahead and check. Okay, all right, and initially, okay, and again, don't check your textbook. This is from different textbook. Your textbook has similar diagrams as well, and everything we talk about the no air resistance. Okay, perfect situation. But if you kick a ball and say, you can calculate, right? You can calculate, or you have a target. Okay, and this is one common lab experiment. You have a target here. You know some initial velocity, you know the angle, you calculate it and you hit it somewhere here. But in real situation, in real lab, if you do that, you wouldn't get the same thing because we have air resistance. Okay, there would be some error. Okay, and this is the real situation. This is the ideal situation where your calculations tells you. Okay, all right. And don't worry about this. If you Google, or you will see these number equations here, and even for web assignments, I am going to provide you help guide with more detailed steps, slightly different from week 1 help guide, and you will see these equations. Okay, and that is for this type of motion, and it says how long it takes to, that means how long this projectile is in the air. Okay, you could use this equation directly for assignments because we have no exams, but in my face-to-face classes, if a person use this equation directly, not showing your work, and even you get the answers, you lose lots of points. I don't know how you get this one, because we are not memorizing any equations. You need to show your work. But for our class, that's okay. Okay, but I will show you how you get it. If you're scared of math, just skip the next slide. Okay, and but if you're curious, let me show you how to get this one. Okay, this is the time to go from here to here. Okay, it has 2 v naught sine theta g. Okay, all right. To get the time, it's easy to use this equation. Y is y naught plus v naught yt plus half ay t squared. This is my equation. I'm starting from here. Okay. In other words, what is my y? For whole thing, y is 0 because it hits the ground. Okay, because this is my 0, 0. Y naught, you're starting from here. V naught y. We know V naught y is V naught sine theta. T plus half ay is negative g t squared. Okay, all right. If I take my, this is 0, this is 0, I can take this term to the left side. V naught sine theta t gives me negative half gt squared. Okay, negative sign cancels out, and I can divide everybody by t, 1 t cancels out, and I'm ending up with V naught sine theta is equal to half gt. I'm getting the t would be, right, multiply to V naught sine theta and divide everybody by g. So that's how you get it to V naught sine theta over g. Not hard, you just manipulate in the equation or arrange in the equation. I did not put any surprises here. I'll put everything you learn up to here. Okay, and this is the time for total air time. Okay, or how long the object was in the air. If I ask how long it takes to go to the maximum height, you can just divide it by 2, or you will end up with V naught sine theta over g. Okay, the next one, range. From here to here, range. V naught x minus x naught is V0 x t plus half ax t squared. So this term is gone, right? Ax0. X minus x naught we call range R. You can leave as x minus x naught is equal to V0 xt. Okay, we know V0 x is V naught cosine theta t. We found out 2 V naught sine theta over g. Nothing new. Okay, alright, you have that. Okay, you can leave as it is, or then I am using some trig relationship. Sine 2 theta is equal to 2 sine theta cosine theta. Okay, and if we use this one, we have here V naught 2. I have 2. I rearrange this one. Okay, so let's say V naught squared. I have g on the denominator, and I have 2 sine theta cosine theta. So 2 sine cosine theta, this trig from math class, okay? And I did not make up this is from math class, sine 2 theta. That's how you get V naught squared g sine 2 theta as R, okay? And if you're doing the lab, I know you have a projectile motion lab, it asks, you will see this equation in your lab manual, and you see that because sine 90 gives the maximum. Sine 90 is 1. If you don't believe me, put your calculator and put sine 90 is 1. Okay, and this is the maximum one. Therefore, if theta is 45, so theta is 45, you get the maximum range. Let me go back to previous slides here, and you see that, see, when theta is 45, you get the maximum range, okay? And that comes, you can prove this one mathematically. See how fun that is? And because you can prove everything. All right, okay? All right, I think I covered everything, and you will see problems in help guide or WebAssign. Again, there are 17 problems. My only advice is, I know Monday is a holiday, but we do not have a holiday, and start early. First listen to those videos and then start the homework, and then you will see those things make sense. All right, let me stop sharing and stop recording now.